Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi Shali Sadri, Vayassali Amri, Walat Ugdata Melasani, Ifawali, Rabbi Zidni Ilma. How is everyone today? We hope that everyone is well. Today we are going to study one more topic, and that is measurement of data storage. It is the topic number is 1.3.1. You can check it in your books also. By the way, the very first thing that we need to study here is memory unit. Just asking, do we humans have memory? Exactly, where you store the stuff, isn't it? Like, for example, you say, I have forgotten, because we humans also have memory. So in a computer, what is the memory doing? It's basically the fundamental part of a computer machine, and this is there to store and retrieve the information. It is there to store and retrieve the instructions. So the way we have in our memory, the different type of instructions being stored because of which we perform different activities. Similarly, in a computer, the same thing is also present in the form of memory unit. Now, very first term that we all may have heard about, that is a bit. What is a bit? By the way, we have studied this thing when we were talking about the conversion. So bit is some a value that you all are comfortable with, you all are aware of. It's a binary digit, which is a 0 or a 1. And this is called a bit. The next term is nibble. When we combine 4 bits, or you can say a 4-bit number is called a nibble. And just to make it a little bit easy, half a byte is also called a nibble. And what is a byte then? 8 bits. When we have 8 bits combination, then that is called a byte. By the way, that's just one thing that we all need to know is byte is the smallest unit of memory. Like we have talked about bits and nibbles, but in reality, the byte is the smallest unit of memory. And although we do have some computers which have larger bytes, but they are always multiples of it. Like we will talk about the computer architecture. In this, we'll talk about the 16-bit systems or 32-bit systems or 64-bit systems. So you can see these are all the multiples of 8. Okay. Now, this is a table to make you comprehend actually. Bit, binary digit. After that, it's KB, kilobyte. By the way, have you heard this term? Kilo. Yes, exactly. Kilogram, kilometer. Similarly, the kilobyte. Next unit is your megabyte. Then next to it is gigabyte. Then it's TB, which is terabyte. Then it is PB, which is petabyte. Then EB, exabyte. Okay, now till this point only. Okay, now after these, there are a few others also that are just being discussed for reference, like zettabyte, ZB, yottabyte, which is YB. But okay, now one thing that you can see here is in all the units, the letter B is in capital. Remember, capital B represents a byte and small b represents a bit. Okay, so wherever you encounter the memory units, you be cautious that small b is always representing a bit and capital B is representing a byte. By the way, one more question. If I talk about the file sizes, the ones that are stored in my hard drive, so which unit out of these is going to be the most appropriate one? The ones that you have seen. Yes, your file sizes. Are they in yottabyte or zettabyte or exabyte? Okay, that's really great. That's great, Ellie, that you can recall. It's basically a kilobyte. This is what you may have observed that whenever you open File Explorer, and then it shows you the file sizes, and the file sizes are in kilobytes. By the way, what about megabytes? The RAM sizes, okay, that's great. What about the hard drives? Which unit do we normally hear when we talk about the capacity of my hard drive? Just your prior knowledge, the ones that we hear quite often, the ones we experience quite often. If you want to buy any stuff, then if you go and buy it and want to buy a hard drive, then you need to know the units. So hard drives have the capacity measured in gigabytes. Exactly. By the way, terabytes, petabytes, and exabytes are also there. Normally, the home users, are normally not encountering these bigger units, but these are still there, which are used on the networking, which are used on the networked hardware. So this is what you will, inshallah, study when you are going to learn computer science in the at the higher level. Okay. But talking about the units that we need to be very well versed with are bits and bytes, then kilobyte, then megabyte, then gigabyte, and terabyte. Well, because we do have hard drives in the form of terabytes also. Okay, any questions? Okay, now again, a very interesting thing. You have studied it basically, definitely, but let's very quickly recap. Kilobyte is KB, megabyte is MB. Again, you can see both of the letters are in capital. Gigabyte is GB, terabyte is TB, petabyte is PB, and exabyte is AEB. By the way, just see 1000. Isn't it something similar that you hear in kilogram, kilometer? Isn't it? Kilo is always representing 1000. So exactly the same thing is here also. When we talk about kilobyte, it means 1000 bytes. So megabyte will be 1000 into 1000. That makes it 1, and then you have 6 zeros. Then gigabyte is a bigger unit. Then we have 1000 multiplied thrice, 1000 into 1000 into 1000. So then it comes to, you can see it's going to be 1, and then you have 6 zeros, 9 zeros. Then 6 zeros are in your megabyte, and then we have 9 zeros with a 1 in your gigabyte. Then similarly, you can see terabyte is 1000 multiplied 4 times, and that is going to give you a higher value. Similarly, petabyte is 1000, which is multiplied 5 times. And similarly, the exabyte is 1000 multiplied 6 times. So in this manner, what you obtain is your answer. Any issues? Understood clearly? Okay. Now, this is very important. You need to know how can we move from one unit to another. So here you can see bit is my smallest unit. Fine, this is what we have talked about. After this bit, you can see, after this bit, it's a byte. And then it's a kilobyte. Then it's a megabyte. Then it's a gigabyte. So if you are moving from bit to byte, you will be performing division and division by 8. After that, if you are moving from byte to kilobyte, you'll be dividing by 1000. Then after that, if you're moving from kilobyte to megabyte, you'll be dividing once again by 1000. And if you're moving from megabyte to gigabyte, you will again be dividing by another 1000. So just remember, in order to move from here to here, first of all, it's byte to byte by dividing it by 8, and then all the others are division by 1000, division by 1000, and division by 1000. So in other words, if I have to move from byte to gigabyte, I'll be dividing it by 1000 into 1000 into 1000. Like I'll be dividing it by 1000 thrice. Making sense? What did I say? If you have to move from, assume, okay, now just let me make it very simple. If you have to move from bytes to kilobytes, you'll be dividing it by 1000. But if you have to move from bytes to megabytes, first stage is you will be dividing it by 1000 to get the answer in kilobytes. And then you'll be dividing it once again by 1000 to get the value in megabytes. So that is what I was saying, that you have to divide twice by 1000. Okay? Clear? Okay, on the contrary, if you are moving from gigabytes to megabytes, you'll be multiplying. Multiplying by 1000. From megabytes to kilobytes, it will be 1000. Once again multiplied. From kilobytes to bytes, you'll be again multiplying it by 1000. And if you're moving from bytes to bits, you'll be multiplying it by 8. So just remember, when you are going from bits to bytes, then bytes to kilobytes, in this manner, you'll be performing the division. And when you are going from gigabytes to megabytes, megabytes to kilobytes, and kilobytes to bytes, or from bytes to bits, then you will be performing the multiplication. Understood? Any issues? Okay. Now, just to make you comprehend a few examples, 1 kilobyte, how it actually has happened. It's in reality 2 to the power 10. That makes it 1024 bytes. But since we have talked about in the beginning, kilo, normally the word kilo is representing a value of 1000, like we talked about kilogram, kilometer. So similarly here also, this is what it is approximately equal to 1000 bytes. Okay, so 1 kilobyte is actually 1024 bytes, but we are going to just talk about with respect to approximation, and that will be equal to 1000 bytes. Now, just to make you comprehend the value for megabytes also, it's going to be 1 megabyte means 2 to the power 20. That makes it 1024 into 1024, and that makes it in reality 1048,576 bytes, which is approximately equal to, you can see 1, and then we have 6 zeros here. So just for the purpose of comprehension, we have understood. I hope that we are clear about this. That kilo means 1000, and then we have 1000 into 1000. Actually, that is going to give me this value. Understood? Any issues? Okay, you can work on others also, like the gigabyte, then others also. But I think this is enough for you people to comprehend that this is how we get the value. Although it is in reality the 1024 multiples, but we are talking about approximately equal to the multiples of 1000. Fine. Now, a few examples. I was asked to convert how many bytes are there in 2 kilobytes. Can we do it? If you have understood, I guess you can do it very easily. Just try it out. Okay, just giving you a hint. 1 kilobyte has 1000 bytes. So it means 2 kilobyte means, okay, that's great, wonderful. 2 kilobyte means 2 into 1000, and that makes it 2000 bytes. So simple. That's great, Eddie. Okay, are you ready for another question? Okay, now it's megabytes. How many bytes are there in 3 megabytes? We have talked about right now, megabytes means it should be 1000 to 1000. So 1 megabyte means 1000 into 1000 bytes. Yes, exactly. I think we all are able to do it. Yes. Ali, are you done? So 3 MB means 3 into 1000 into 1000. If 1 MB means 1000 into 1000 bytes means 3 MB means 3 multiplied by 1000 multiplied by 1000. And the answer will be 3, and then we have 6 zeros. Again, a trick. 3 zeros here, 3 zeros here, 3 zeros here, 3 zeros here, and 3 into 1 is going to be 3. No calculator exactly, but still we have learned the techniques of answering faster in this manner. Fine. Any questions? Okay. Now we have talked about the kilobyte. Now, actually, in reality, the unit that we need to know is kilobyte. And that is presented as K capital, I small, and B capital. Again, the same. Capital B represents a byte. Megabyte, M, I, and B. Gigabyte, G, I, and B. Terabyte, T, capital I, and B. Again, you can see everywhere the letter EI is in small, and the letters K, M, G, T, P, and E are in capital, along with the letter B. Then petabyte is capital Pi and capital B. XB byte, capital EI and capital B. Okay, are you clear? Gibby, maybe, Gibby, Debbie, Pebby, and XB. Okay, now what is the number of bytes here? In the powers of 2, like the powers of 2 to the power 10, 2 to the power 20, 2 to the power 30, 2 to the power 40, 2 to the power 50, and 2 to the power 60. Okay, now what is it equal to? I mean, this is what you need to know. 1024, and I think it's not a difficult thing for us to remember. And you can see the other units are simply 1024 into 1024. That makes 1048576 bytes. By the way, just telling you, don't get anxious that you have to learn all these values. No, not at all. What you need to know is this. Like, for example, megabyte means 1024 multiplied by 1024. Similarly, gigabyte means 1024 into 1024 into 1024. Then terabyte is 1024 multiplied 4 times. Then petabyte is 1024 5 times multiplied. Then XB byte is 1024 multiplied 6 times. Are you clear? This is what we need to know. And besides this, you can even remember this also, the sequence: power 10, power 20, power 30, power 40, power 50, and power 60. Are you clear? Any issues? But this is something that we need to know. So kilobyte, then megabyte, then gigabyte, then terabyte, petabyte, and exabyte. May I move ahead? Okay. The way we have talked about conversion from one unit to another. So very simple. If you have to move from Gibby to maybe, or from maybe to Gibby, you are going to perform the division. Just remember, when you are going from this position to the bottom, you will be performing the division. And on the contrary, if you're going from here to here, then you will be multiplying. For example, if you have to move from megabytes to kilobytes, you will be multiplying by 1024. But on the contrary, if you have to move from kilobyte to megabyte, then you'll be performing the division. By what? Yes. If, for example, I have to move from kilobyte to megabyte, I'll be performing division. I hope that we all are clear about it. But by what? That's great, wonderful. By 1024. Okay. And if, for example, you have to move from bytes to megabytes, then exactly, then you have to go with 1024 into 1024. That's really excellent, Emma, that you're able to understand and answer. Just remember, very simple principle: when you are going from kb to gibby or other below, then you will be performing the division. And on the contrary, if you're moving from gigabyte to kilobyte, for example, then you will be performing multiplication. And definitely it is going to be based on the value. For example, if you're going from gigabyte to kilobyte, they will be multiplying by 1024 into 1024 into 1024. Okay? Any questions, any ambiguity? And remember, these are your IEC memory size system. These values are supposed to be answered based on 1024 and its multiples, not with 1000 multiples. Okay? Any issues? Okay. Now, the way we have done the work for the normal kilobyte, megabyte, similarly, now we are learning how can we perform this from bits to bytes, the same, division by 8. Similarly, from bytes to bits, again, the same, multiply by 8. But if you are moving from byte to kilobyte, you'll be dividing it by 1024. If you are moving from kilobyte to megabyte, you'll be dividing it by 1024. If you are moving from megabyte to gigabyte, again, you'll be dividing it by 1024. And again, it's the same thing. If you're moving from here to here, you'll be dividing it by 1024 into 1024. Any issues? Similarly, if you're going from gigabyte to megabyte, you'll be multiplying it by 1024, then megabyte to kilobyte, again 1024, again one more 1024. You're going from kibi to byte, again by 1024, and you're going from here to here, you'll be multiplying it by 8. This is the same, But as far as the other units are concerned, the only change is it's now 1024 and not 1000. Understood? Are you clear? Okay. Now let's do a few examples. I hope that that will really be of great help to you in answering the questions that are coming in the paper. A new computer comes with primary and secondary storage. Data storage is measured using binary denominations. Complete each conversion. Let's see. 8 bytes has how many nibbles? By the way, 1 byte has how many nibbles? Since 1 byte has 2 nibbles, exactly, that's great, Ali. That is why, how many nibbles will there be in 8 bytes? That's great, wonderful. It will be multiplication. As you can see, the way we have talked about right now, you will be performing the multiplication by, in the same manner, 1 byte has 2 nibbles. That is why 8 bytes will have 2 into 8 or 16 nibbles. Easy? Okay, another question. 512 kilobytes. Fine. How many megabytes are there? See, now I have to move from kilobytes to megabytes. What will I do? Since I know 1024 kilobytes equals to 1 megabytes. Now, just be very clear. Since I have to find out megabytes here, that's what I wrote megabytes on the right-hand side. Just the same conversion that we, like the same calculation as we do it in math. It's exactly the same. Fine. So no worries at all. 1024 kilobytes equals to 1 megabyte. So it means 512 kilobytes will be equal to how many megabytes? What will I do now? By the way, will I do the division or will I do multiplication? I'm moving from kilobytes to megabytes. Dividing, that's great, Ali. I'll be dividing it, and that will be simple, very simple math calculation, the way you do it in math. It will be 512 kilobytes means 512 divided by 1024, and that gives you 0.5. Or you can simply say 1 upon 2. That's perfectly okay. Fine. Are you clear? Any questions? See, I have to move from kibi to mebi. So here, this is what we have learned, that I'll be performing the division. Division by 1024. The value is this one. I'll be dividing this value by 1024. And what you get is 0.5. By the way, again, very simple. 512 times 1 is 512, and 512 twice multiplied by 2 is 1024. Just simple. These are simply the multiples. So don't get worried. Don't get anxious. This is what we actually have been doing, and we don't have to worry about it at all. Okay, now, next question. How many megabytes are there in 4 gigabytes? By the way, what will I do? Just one simple principle. 1 gigabyte has 1024 megabytes, or equals to 1024 megabytes. So how many megabytes will be equal to 4 gigabytes? Will I be performing division or will I be performing multiplication? I am moving from gigabytes to megabytes. That's great. Excellent, Ali, that we are going to multiply. Exactly. You can see 4 gigabytes means 1024 into 4, and that gives you 4096 megabytes. Easy. Now, the next one, very simple. 1 exabyte has how many petabytes? So 1 exabyte equals to 1024 petabytes. So simple. But in case they had asked you about maybe from exabytes, they're asking you to move on to gigabytes. Then definitely it will not be once you'll be performing multiplication based on how many values are supposed to be used here. Okay, now is it easy? Yes or no? By the way, this is one of the past paper questions which we have done today. I hope that you have understood this. Any questions? And I hope that you will be watching the next video of calculation of file sizes, and that will definitely be very helpful. This presentation will be very helpful in understanding that video also. Please do watch that video. Write it in the comment if you have any questions, if you want me to make the video on any topic. Jazakallah khairan kasira for being a part of the learning journey. If you have liked my video, subscribe the channel, share with your friends and family, so they all are going to benefit from it. Take very good care of yourselves and your loved ones. Allah Hafiz.